Problem 119 is dealing with another version of the screamer. And with this problem here, we have a circular track. It says that the radius here of the circular track is 100. And the center point here is going to be 50 feet below ground. So if the ground level would be about here, this would be then down 50 feet. It also states that passengers are going to be boarding from the top right here. So what this would look like if we're writing a function, as it states here, from the starting point to the height of the rider. So if we looked at a graph of this, they're going to start up top, they're going to move down, and they're going to continue going like this. This is going to be represented as a cosine wave, and the reason why is because they're starting up top. So, taking a look at this graph, since I am starting off with a cosine graph, it is going to be going up and down from the center line here, the radius, which is 100. That is going to be my A value, the amplitude of the graph. I also know that since it is 50 feet below ground, that is going to give me a K value of -50. With that information, I can write my cosine graph. It is going to end up being then y equals 100 times the cosine of x minus 50. We could go through and draw a sine graph for this as well. If we want to do a sine graph, we would need to start the graph right over here, and that would involve an h value. But we can also represent it with a cosine graph.